again everybody. Today we would be discussing the components of the blockchain. One of the component of the blockchain was discussed in the previous video, that was the node. We have discussed that node is any physical commodity or the physical component which is being added to that particular network. So that particular hardware component can be your computer, or I should say your laptop, your mobile device, which is being added in that particular network, in which it should have an internet connection along with it. So the hardware component, or your laptop, your desktop, or your mobile phone which is connected with an internet can become a node in this particular blockchain. So we have discussed there were two types of the nodes. One was the full node, which has all the history of the transaction from day 1 to the current date, and second was the partial node or the light node, which keeps only the partial, or the light node which keeps only the whole transaction history, and this partial node only keeps the block headers, and they rely on your full nodes. So this was which we have discussed in our last video. The first component, that was the node. So node is any hardware component which is being connected with the internet, and second is there are two types. One is the full node and the second is the partial or the light nodes. We have all that particular transaction history in the full node, so we usually prefer these particular full nodes. But if we have memory shortage or we are a nearby user, then we go for a partial node, so that we can only match that particular block header and then verify that particular transactions. Next comes the ledger. As we have discussed this particular ledger, the ledger is a copy which is there with each and every node which is there in this particular network connection. Okay, this is a distributed connection which is there with each and every node, and each node has a local copy of the transaction history. So you have a digital database of the information that is immutable, which cannot be changed. Even if they have the local copy, they cannot change the previous transaction. If this is the T1 transaction and this is T4 transaction, so if this is P2 node, so P2 node cannot change this particular data of the T1 transaction. So all these particular digital database should be immutable. So blockchain is basically referred to as public, distributed, decentralized ledger. Obviously, public is anyone in that particular blockchain has the access to that particular ledger, can read that particular ledger, and can verify that particular transaction is being done or not. So that is basically like a hoarding which we have on a roadside. Everyone who is passing that particular road can have a look at that particular hoarding. So here the ledger, any person which is there in this particular blockchain network can have access to that particular. These are five persons who are there, or 5 nodes which are there in the blockchain. If a 6th node comes and adds, then they would share this particular local copy with this particular 6th node also. So this tells that the ledger is public. Anyone can come and join this particular blockchain and have a copy of this particular local ledger. Then the ledger is distributed. Obviously, all the nodes in the blockchain has a copy of the blockchain ledger. See, each and every person is having a copy of this particular ledger. So, how does this particular ledger is distributed differs? In the traditional database, we have a client-server environment, and in this particular client-server environment, only the server has that particular database at a single location. But in a blockchain, it has a replicated data on each and every node. The data is being replicated on each and every. As I told, we have a local copy of the data or the transaction history on each and every node. That is, we are replicating that particular data. But in traditional database, replication is prohibited. We don't want replication of the data. So we keep that particular data on the server, and all the clients are accessing that particular data. So then comes, see, public we have done, Distributed we have done. Then comes decentralized. So what do you mean by decentralized? The blockchain protocol can build such that no one node or going to a group of nodes can exercise control over the ledger. Not a single person can have a full control on this particular network. The rights are being distributed, equally likely option, equally applicable rights. Each and every person has all the rights to do whatever they want to do it on that particular blockchain. So this is decentralized. We don't have a single or a central control authority where only a single person has all those particular rights and exercises those particular rights. So obviously the ledger is public, open for all. Anyone who is coming and joining this particular blockchain network can have a local copy of that particular ledger. It is distributed. Each and every node in this particular blockchain has their own local copy, and that should be synced with each other. Okay, as in when there is a change in a single copy, see if this particular user is making a change, then it would distribute to each and every person here, and they would have a similar copy. Decentralization is no one is having a right control. Each and every person is equally likely or have equal controls on this particular ledger. So there is no central control, that is centralized with no single point of failure. As it is decentralized, so we don't have any point of failure, as all that particular data is distributed. In traditional databases, we had it works on the central principle of integrity, but in the blockchain, anyone can validate it. See, so first I can tell the difference between traditional database and the blockchain. First, it was in the traditional database, no replication of data was there. Okay, here we have replication of data, like by keeping the distributed ledger. These are the basic difference. Okay, this is the first basic difference which you have seen in the last previous slide. Second is it works on the principle of integrity. Only authoritative people can validate. If I don't have a right to update the data, I cannot do it. I can only view that particular data. If I don't have a right to update or insert in that traditional database. But in blockchain, each and every person has equal right. Each node has equal rights. So they can do it. Anybody can validate that particular record. So validation can be done. Validation possible by everyone. Okay, then the third is, when we are having this particular traditional database, we use a CRD technology. These are three broad differences. CRD is create, update, read and delete. So that is create, read, update and delete principle. The traditional database works on a CRD principle. So that is, you can, if I want to change something, then obviously I will update it. If I want to delete something from the data, I will use a delete option, or if I want to insert some new data, I will use a create option. So it works on the principle of CRD. But in the blockchain, it works on the principle of append only. We are not making any changes. Why append only? Because these are immutables. Keep these particular words into mind. So replication is distributed ledger. Each node has validated that you have a local copy of that particular database. Each and every has equal rights. That is, integrity of data is being maintained. And the third one is we can only append data in the blockchain. And so this is because we cannot change any data. We cannot have a temperness or a updation in that particular data, so as each and every record in the blockchain is immutable. So these are three basic differences. We will have a number of things, as we cannot update. This one is a faster one, this is a slower one. So we will have a tabular form for all this, but these are the three basic differences between our traditional database and a blockchain database, as we are discussing distributed ledger at the point of time. So this is where this is a 7-mark question which usually comes in AKTU. So the next is the third component, that is the wallet. What was the wallet? A software program which we have on each and every node, which keeps a digital wallet. How we manage that particular digital wallet? As we are telling digital wallet, so obviously we should have that particular cryptocurrency into mind. So for with the blockchain wallet, we can receive and send the cryptocurrencies. I can receive and I can send also. Okay, so wallet is a misnomer real money. As we have a real money wallet, similarly we have this particular digital wallets. So if a person A is being sending something, then it is signing off by ownership, that is the digital signature is being done by the person A. If a person A is in effect signing of the ownership of coin to a person B, then obviously a person A would write a digital signature, give a digital signature on that particular coin. For digital signature, what we have seen, we have to encrypt it by using the private key of person A. Then person B can spend a coin only if private key stored in person's B wallet matches the public key address. So first, by digital signature, it is encrypting by the private key of A and public key of B. This encryption is being done in the first step. This is the first step. In the second step, how B would see? B would see is by decrypting it by B's private key and A's public key. Okay, so the person B can spend coin only if the private key stored in person B's wallet matches the public address. This public key matches with the private key, then it can decrypt that particular currency. If the key matches, the balance in the B's wallet increases and the balance in A's wallet is being decreases. Okay, so B gets that particular money if there is a match between the public key of B and the private key of B, along with the private key of A and the public. As the public key of A is given to everybody, so for here the main match should be the public key of the B and the private key of the B. Okay, so it should be noted that there are no real coins. No real coins. We have only the digital coins which is taking part in this. So the set transaction is a new record added to the blockchain along with the change in the balance in the cryptocurrency. If A's balance has been reduced and B's balance has been increased, so we'll add that particular block in that particular blockchain. Only this particular digital coins are taking place. Virtual transactions are being taking place. So it provides all the features that are needed for safe, easy, secure transfer of funds between the two parties. So privacy is maintained whenever a user creates a wallet. How we maintain a privacy? So for maintaining this privacy, whenever the wallet is created, we are creating whatever we have discussed. We create a public key, a private key associated. Then we will see what are these particular public and private key associated with the wallet are generated. I have given the example, your email account is the public key and your password acts as a private key. So you have a identity and the personal details are kept private. So the private key is obviously you have to identify, you have a digital signature. So the privacy is maintained whenever a wallet is being created. The transactions are secure. How the transactions are secure? It sends funds as well as open encrypted message. This keeps the transaction secure. So whenever you are signing by whenever I'm using this private keyword, then obviously I'm doing a digital signature. I'm authenticating myself that I'm the user who is sending it. So when the private key is being used to send the funds, and obviously we are using this particular encryption method, so we are keeping that particular transaction secure. I'm the user who is sending it, like signing a physical check. Then ease of use, the wallet is being installed. We can install it on any of the web, your desktop or your mobile devices, and transfer the funds relatively instantaneously without the geographical locations or the intermediary banks are required. At any location you are there, immediate transactions takes place, and we don't require any third party to take part into the picture. Like whenever we are doing NEFT, and if we cannot instantly transfer the money, so it tells it would do it in 24 hours from the time where you have started the transaction. Here we don't require that particular intermediaries like bank. And the currency conversions is very easy. Obviously, when I'm I started the transaction in India, I would be using rupees. If I do that in US, obviously we would be using dollar. So we have to use that currency conversion, and it becomes easy. We can do it without worrying about, by paying a small transaction fee, we can do that particular conversion, and we can transact with each and every person all over the globe. So this comes out to the third component, that was the wallet. Now the fourth component is the nonce. Obviously it is a number generated randomly, as we have discussed. This is the random number generation, and it can be used just once for a cryptographic communication. It is not so that I have generated a number. See, if I have generated a number R1 as a rand number between 0 to 100, 4 decimal places, then this R1 can be used for n number of transaction. It would be used for only one transaction. Whenever there is another transaction, then we generate another random number. That random number can be between 0 and 1 with 5 decimal places. So for each and every time we generate a new random number, maybe within the same range with the same decimal places, but a new random number is generated for each and every transaction. So adding that particular nonce to the transaction identifier makes the transaction more unique. Along with the timestamp, we are adding one more random number. Okay, that is the nonce. So it reduces the chance of duplication of the transaction. How if that particular time can be replicated, but this random number which I have generated when that particular transaction was taking place, the same random number cannot be generated, very less probability of generating the same random number on any other PC which is being, or any other node which is taking part into that particular blockchain. So for using that particular characteristics, we are reducing the chance of duplication of that particular transaction. So nonce is a key to create a block in the blockchain along with your timestamp. Then comes the hash. So hash function can take place of any size, perform an operation on it, and return a hash, that is the data of the fixed size. So hash is basically we have a fixed size data for any size of the input. Okay, see, if this X is my message, okay, then I generate a hash X. Okay, this is of fixed size. This X, the message can be 2 word, this message can be a paragraph, or this message can be a word. We would generate the same size as we have discussed. We take SHA 256 algorithm usually for hashing. What does this SHA means? Secure hash algorithm. Okay. Now what this 256 means? That is 256 bits. It would generate 256 bits if the message has 2 words, or the message has a paragraph, or that particular message is of 2 pages also. 256 bits or 64 characters. Okay. So here, whenever it is a single sentence or the Oxford Dictionary, of the resulting hash will always be of the same size. Here is the catch. The catch is it generates the same size. Okay. The critical characteristics is it create almost unique. This is an alpha numeric. Okay. So it almost unique identifier. In whenever you see a BC, that is the blockchain. In blockchain, hashes are used as identifiers for the block transaction and the addresses. In the blockchain hashes are 256 bits or 64 characters, as we have discussed. The hashing algorithm which we usually use in blockchain is SHA-256, where SHA stands for Secure Hash Algorithm, generating 256-bit hash. So these are usually alpha. It is one directional. Obviously, we can generate it. We cannot regenerate that particular hash again. So a right candidate for encryption who has generated that particular hash, the hash function can take a string as the input of any length to generate a, here the main thing is we are generating it of the fixed length output. Okay, so cannot take the data output and regenerate the string input. Obviously, because we have generated 256 bits from a 2-page data, we cannot regenerate that particular string input. So a very minute change gives a different hash, making it one of the most secure function. So basically, this is these are also our alpha numeric values which are being generated. This 256 bits are alphanumeric values. So in the coming slides, we would be see. So a very minute change in the text, in the input text. Here, minute change in input text would generate a very massive change in the hash which is being generated. It keeps the database very small as the size is the size is fixed, so it keeps the database small as the data output is always of the fixed size. For example, if I have to store a file, original photo along with the signature, it would be obviously saved in the form of 256 bits only. Not more of the data would be required to save that particular photo along with the signature of the person who has created that particular photo. So only the hash needs to be stored in the database, since the hash is mathematically associated with the original painting of that particular data. So a hash is a 64 alphanumeric character, creates an astronomical number, and the combination, so a very little change of a little change of in the data can create a duplication in that particular text. Okay, so how do we see this particular hash function, or the points which I have in my previous slides, like a minute change can give a different hash change. So we would be seeing that into this particular slide. So if X is the message and the HX is the message digest or the hash key which we have generated, a small change results in a very significant change in the output, and this is called as the avalanche effect. Okay, so avalanche effect is a minute change in the input data creates a very large change in the output data. So here we can see this particular example. The first input has only the word as fox, but it is again creating a 256 bit or 64 characters output. Now second line has the red fox jumps over the blue dog. So it is generating this particular text. Here only the spelling of over, that was O-V-E-R, now I have changed to O-U-E-R, and there is a massive change in this particular hash. This was changing a particular character or an alphabet. Here I have not changed the alphabet, but the order is being changed. O-E-V-R. Again, a new hash code is being generated. See, there is a massive difference between these two or these two. Okay. If some particular characters is being deleted, here from over, I have O-E-R only. Then again, I have a new hash function which is generated. So for a single change, a single alphabet is being changed, so massive change. A single alphabet places are being exchanged, a massive change, or a single character is being deleted from that particular message, a massive change or an avalanche effect can be seen in this particular hash function. So in the coming videos, we would be discussing how we generate this particular hash key for the blockchain and continue with the components of the blockchain. Thank you for this video.